Hi, everyone. Thank you so much for being here today to the first morning session of the Transform track. Hope everyone had a good party last night. We have with us Andrea Gallego. She is the CTO of the BCG Gamma, the Boston Consulting Group's data analytics and AI wing. And I'm super excited about this talk. I'm a data engineer myself at Docker, so this is pretty exciting. Her talk is entitled The Complexity to Yes in Analytics Software and the Possibilities with Docker Containers. Looking forward to it. Feel free to use Twitter, tweet at DockerCon, and enjoy. The floor is yours.
Thanks. Do you guys have a clicker? A clicker for the page, for the PowerPoint? So I can walk around. You guys are getting one? All right, I'll start in the meantime. Hey everyone, thanks for showing up. This is the first time I think BCG has ever spoken at DockerCon and likely another technology conference. So this is an exciting time for us. So I'm going to have a brief agenda, just level set everyone on BCG and Gamma, just in case you guys haven't heard of the analytics practice. It's fairly new at the firm. And then I'll immediately start getting into how we're innovating ourselves at the firm and how we're helping our clients innovate. Some of the additions and edits that we've ourselves made to DTR, and what's coming next in the pipeline for us and Docker. So we have a growing partnership with Docker, and we're creating some new IP with them over the next year or so, and then I'll open it up for Q&A. So I think a few of you know BCG in its classic sense, so I won't go over that. Since then, we've added Gamma. Gamma is, if you think of a buzzword today, that's what we do. So if you AI, blockchain, ML, anything around scale and engineering when it comes to analytics, anything around that kind or sort of topic, that will go under the Gamma umbrella. We have a technology office inside of BCG's core, which is more about strategic design and technology. We've partnered with Mu Sigma, which is our capacity house. So when a client tells us, hey, you don't have 4,000 engineers like another typical competitor would have, we say, yes, we do. We acquired Platinian, which is the legacy integration system team, which if you have a huge piece of legacy IT or infrastructure and you need to find out how to modernize that, Platinian has the expertise there. And some of the more interesting work, when all of these components of BCG come together, a lot of clients come out with new business ideas, and those new business ideas become ventures and become funded and set out by BCG, and that happens at Digital Ventures. So you can see that BCG has really, this is probably the past 5 years that we've gone from strategy all the way to end-to-end delivery. But who's Gamma, right? I obviously am the CTO of Gamma, so I should spend more time on that. We're over 500 analytics practitioners, consultants, engineers, and we do, what everyone else does, right? So we're the intersection of data science, engineering, and production and design. So our number one question is, if you have a machine learning model or if you have some analytics, it's not exactly clear how to actually productionize that today. A lot of our clients have questions around, this is really cool, the model's nice, but if I can't put this model into production and integrate it across, 400,000 retail stores, then it's not going to work for me. And our job is to ensure that that can happen in market. Gamma X is our newest endeavor inside of Gamma. So what we realized at Gamma was we have data scientists, we have a lot of machine learning people, but without software engineering, without systems administration, that model is going to go absolutely nowhere. So we've built out a team of over 30 engineers, not only specializing in systems, but specializing in systems as they apply to analytics. So with very core specialty in, well, how will this work for FGPA computing? How will this work with computer vision? How will this work with convoluted neural networks? Can you unit test a convoluted neural network? Can you scale one in containers? Can you find a way to locally distribute a system that has 4 containers that need to talk to one another, deploy that, and still find out if the managers and the masters can talk to one another? It's very new. It's some of that is research. Some of that we're working with a lot of educational institutions on. But those are some of the topics we work on. We're building our own software. I'll talk about that. And we have other things that are very new to consulting, like SLAs, which typically doesn't happen in a consulting firm. So this is just quickly to say, when we go to our clients, when we talk to them, we deliver end-to-end now. So we deliver like any other software company in the sense that we have the end-to-end software supply chain. We go from incubation all the way to production and delivery. And what's interesting about that is we don't just do that with software at Gamma. We can do that with a strategic use case. We can do it with building out an analytics center of excellence. But anything like that, we ensure that we go to full production state and leave our companies fully enabled. But when our clients look at us, they go, there's no way you're doing that with a deck, and you've just showed up with a 150-page deck. So we need a demo, we need some software, we need some way for you to show us that you can do this with more than just PowerPoint pages and 3 consultants. So we started thinking, okay, can we actually build a piece of software that makes it possible to do the following? Run models on any kind of infra, yeah. Access data, sure. Provide clients with output, okay. Test models against production grade standards, maybe. Deploy models, probably. You know, share models that are secure, sure. Share model code and output, okay. The last one is tricky. Can we deliver models at edge with real-time orchestration, monitoring, and model updates? So we thought we might as well give it a try. And that's how we started the Docker journey at Gamma. So we've built our own system. The name of that system is Source. This is a use case, and then I'll dive deep into the technology of that use case. What we have today is a system that's akin to the other ML systems you've seen in the market, with a few nuances. So you log into the system. You can use your IDE of choice. You can use a Jupyter notebook. You plug into GitHub. You submit your code as wanting to start training your model. As you start training your model, we have a number of systems on the back end that are ensuring containers are running, containers are building, your models are being linted and ensured for consistency. All of your data has lineage and provenance. And we have 2 methods of pipelining in our system with an exclusive company called Pachyderm. And those are data pipelines and model pipelines. So we ensure integrity, consistency, and lineage across both models and data, because we don't think that you should just be checking your models for consistency, but any data transformation you do should also be checked for full lineage and provenance. And this is important for us because all of our clients care about GDPR, right? Then we have Vault, which is a HashiCorp tool. We ensure that, and we'll talk about this later, that absolutely zero SSHing for hard-coded PEM files and containers, any other kind of user data or automatic user keys or credentials are all managed by Vault dynamically. There is no manual touch point with any kind of keys in Docker or otherwise in our system. We then go into DTR. DTR will then manage all of the final encapsulated containers with no dead-end code path. That means that there's a ton of systems that you're running in our managed service that have our containers and our builds and our technologies. But when a data scientist is ready to release that container to the market or to a client, it gets fully encapsulated in an independent way so that you can use that container and that model anywhere. This is a deeper look at the architecture. So you can see we're using Kubernetes. We're not using Swarm. We're using DTR. We're using Vault. We're using Circle CI. We're on AWS, but you can use this software on anything else. And you can see that most of our proprietary code and our work goes into all of those wonderful, magnificent arrows that are going in every direction, right? So how have we stitched all this together? How do we make sure it works? Our deployment, we've done a few chaotic blow-ups of our system, and it takes very, very little time to bring this entire system back up with a few Terraform scripts. That's all right. Yeah. So at the beginning, we started with vanilla Docker. What did that mean? I mean, you guys all know how DTR gets set up, so I won't go through the very detailed steps here. But essentially, what this means is when you do the full DTR setup, you have passwords and credentials that are hard-coded. You don't have high ability just yet. You have no dynamic means and low confidence of consistency and very little leader election for finding out what happens. If one of your managers or your masters goes down, how can you automatically spin that back up? So we fixed it. In our system, no information is stored in the user data or in our TF states. There are no PEMs on any instances, no private keys. There's no SSHing back and forth. We have fully dynamic, and we avoid all race condition. We bootstrap extremely easily, and we have full HA on DTR. This allows us to spin up incredibly quickly, and we are now discussing open sourcing this to the community in a full TF build, Terraform build. Oh, I'm out of. Actually, nothing like running out of battery, right? Can I plug in? No. And in terms of production timing, to give you guys an idea of this, I started at BCG 11 months ago. I hired my first engineer 6 months ago, and we've gone into production a month ago. So we're working pretty quickly. We're at 30 engineers now. So we have 200 business as usual containers, 20 plus containers with each new user application. So every time we add a user, a client, a front-end application or service, which is essentially running an entire model and data pipeline build, we add 20 new containers. Our front-end services have 19, Circle CI and the Circle CI services have 44 containers. We have Terraform Enterprise, and UCP and DTR with replication has 75 containers. And our applications will grow, obviously, fairly exponentially as we scale. So what's next for us? We had a few discussions with Docker, and we asked them two questions. One, we needed to be more secure across the entire software supply chain. And secondly, we still had an issue with our clients. When you deploy this container to another environment, how do you plug the thing in, right? So, okay, I can run this thing, I can put it on my laptop, or I can put it in a data center, but now I have to open this container, I have to find out what the I/O is, I have to find out what data input I get, I have to see what to connect the score to, or whatever this thing runs on. How do I do that? So we are working with Docker to do two things. One is we all have image signing. Image signing is not new to Docker, but we have to be a little unique in the sense that we have two DTRs that are fully replicated because we have an internal trusted registry for ourselves and our work, and an external registry when it's ready to get released to the client. That image signing will happen across that entire supply chain so that when we send a Docker container to an external client, whether it be a major company or a startup, we can ensure full consistency of that container and really make sure that it's ours. It's also a nice little warranty so that if they break the seal, the warranty is void in terms of our SLA. This is the fun one for us. So we've asked Docker to help us with a solution that could deploy our containers in two ways. One is essentially have a DTR mothership that will send a container out with two options. One is a ping back, so an open of a network that only is externally, for us to be able to gather all of the metadata and information of that container and manage it for them 100%. So we can find out when you need to scale up, we can find out if you're running out of memory, if you're having issues with your model, and we can provide hot real-time updates to your models and all of your parameters, if you need tuning, things like that. The next option is you're a government client, you don't want to open your network to absolutely anyone, so we release another lightweight container, and that container is essentially what's like Gonglia for Hadoop, right? It's a UI that lets you orchestrate and monitor that container from a very easy to use kind of plug and play interface. Now, there's something else here that we're working on, and that's two wrappers. One wrapper for all major ingress points will go with our container. All major ingress points are all major databases you guys use, right? So HDFS, any Oracle database, Postgres, you name it. And another wrapper for all egress points. TIBCO, Spotfire, Tableau, name your other BI tool. Those wrappers come together with the container, so now you don't have to integrate. You now have a toolkit that allows you to connect your system to your data and your container to your output. You lock it in, and you have an entire end-to-end system of going from data to analytic output. That will be coming. I have a few engineers of mine in the room, so I'm not going to give a timeline or they'll quit. It'll be coming soon. Of course, a lot of this depends on Docker's technology and the IP we're working on with Docker. But a lot of it also depends on how quickly we can scale, how many engineers we can hire, and how quickly we can test these sorts of deployments. So with that, I'll leave it up for some Q&A, and I'll also, for some of the questions, I'll put up the email of the lead back-end engineer that created our DTR upgrade, in case you have some really deep-level questions, but I can try to answer whatever you guys have.
I have a mic in case anyone has any questions. Please ask questions or I'll start and ask very annoying questions, long, winded ones. Okay, I think I will. Sure, last try. Because then you can hate me now. Andrea, how do you think this ties in with eventually, I guess, eliminating the need for data engineers? If we are able to programmatically have things, if it's so easy to just plug and play, how do you see data engineering evolving over time?
Yeah, so I'll plug in our website real soon. But so the one thing we like to say with our tooling is there are a couple of other companies on the market right now that do a lot of auto ML and automation of everything. We don't want to automate two things. The creation of the algorithm and the model is something that we still think is fairly unique and should be transparent, even if you want to use a base model that everybody uses that's known for its domain accuracy and maybe CPG. Same thing goes with data engineering. So our experience at Gamma, my personal experience, has been that even though you may have some great tools that will automate the data transformation space, right, you still don't know how unique the customer's data set is until you get there. And so yes, we will start having libraries, et cetera, but those libraries will do things like many other companies do, turn a data set from categorical to nominal. Right? But, you don't really know. For example, we worked on Starbucks for many years, and we hyper-personalized their journey in their web app. We wouldn't have been able to do that with a typical, data normalization feature in another tool.
And you mentioned, databases, Postgres, we can have MongoDB. What about connecting with AWS, databases? Because when you come to Redshift or DynamoDB, how does that play out in the future?
Yeah, so two of the things we're working on, I can bring this back up now. Two of the things we're working on with not only AWS but with Azure is we're going to have source deployed on the marketplace. So we're working with AWS Marketplace right now, and we're working with Azure to ensure that you can actually have this spun up in AWS and fully integrated. Yeah, it'll take some time because, as you guys know, same thing with Docker, we will also be Docker certified. The same thing, they have to go in and make sure that you can actually click a quick setup button and there's an AWS document to spin up the tool. But if you don't want to have it on our system as a managed service, then we'll have the ability to do that. So we'll have native connectivity. Same thing with GCP. One of the things we'd really wanted to do was connect this into Spanner. But there's still some questions about how much Google wants us to know about integrating with Spanner. So we'll get there.
Still open to other questions. I can continue for an entire hour. So you mentioned, I think, GDPR as well. What were the challenges that have come up with GDPR and then monitoring compliance, I guess, as data flows in through the pipelines? Yeah.
So the biggest issue right now with GDPR is there really isn't one system that shows you everything. What you have to do is either plug a few things together into something like a Splunk or a Sumo Logic, but then you still miss some lineage and you miss some provenance, because if someone downloads a data set to a local laptop, makes a change, and uploads that change, you actually violate GDPR convention. So data chain of custody, I am still curious as to how someone is really going to be able to prove that, unless you're in a system that doesn't let you download any of your data locally, how you're going to get there. We're trying to get there, but I'm going to sound very corny BCG-ish, but that's a lot of change management. I mean, if you go into a company and say absolutely no one can download any data to their local machine, is it really going to happen? Is it really not going to happen? Is an interesting question. But it is really how you get to the point of, or you create an incentive like we've done in Source as well, where, listen, you want to productionize your model. It has to hit our GitHub. It has to go to, you have to merge it in and you have to check it in. And then when we do that, we at least ensure some level of consistency. But I think that's going to be the biggest issue. And then just managing we're never going to leave legacy IT. And so how are we going to get to a situation where you can do this all with one program? I don't see that happening. And so integration is still going to be key. And why we've stayed in that space, which is maybe a little less fancy in the kind of AI world, we've stayed in the infrastructure and system space. Because honestly, I think that is where the pain is right now. I don't think the pain is developing the coolest neural net. I think that's been done. It's very cool, and a lot of people are doing it. But then, how do you make sure that the systems that run that neural net can actually function is actually quite complicated. And it'll be the same thing for GDPR, because that's what they care about, right? They don't care about the neural net. They care about, well, how do you make sure that the data flowing into that thing, we know what it is, we know where it is, we know how it's managed, how it's tagged, we see all the metadata. And that, I think, is going to be a systems issue for a while. Yeah. What? Yes.
So looking at this, the first thing I think is, all right, super cool, but what are the plans for managing a blended on-prem and cloud/off-prem solution? If clients have a hunk of data that they can't let move anywhere, but they want to do an analysis with another hunk of data that they can.
So, yeah, so obviously, if no one wants to move, listen, at the end of the day, if no one wants to move data off-prem at all, even to do a test in our managed service, we have to do a full custom install of Source on their environment. The full stack all the way up in Terraform in their space. Now, if they allow us to do some testing in our tool, right, then they just get the container. It sits in their environment, and they can feed in the rest of the data. The trick to this is getting the data scientists and the analytics team to write scalable algorithms that have dynamic input. Now, for computer for computer scientists, we get that. And for systems engineers, we get that. You have to make things dynamic, because if you hard code them, they can't leave your system. Data science, not so easy. So we have to ensure that those two things can happen, right? That we create, and our containers do that, right? So we have everything is dynamic, so that it can feed into any system and egress into any other system. But getting the people to actually write those models and not having to build an entire refactoring team is still to be seen.
I'm also curious to know, at what point did you decide to approach Docker to kind of get things done? What was the thought process like? What were you thinking at the point?
Yeah, I have a good relationship with Docker. It was my original choice between joining BCG or joining Docker. So I was actually going to be a Docker employee a year ago. So I had a good standing relationship with them, and we just figured that this was going to be, one, they were really innovating. I had known about their work at the CIA. I had known about the image signing work. I had worked on it myself, just playing around with it as an engineer. And I thought the fun place in 5 years, and I was just talking about this to a researcher downstairs, is going to be actually distributing at edge, distributed analytics applications that can talk to one another. And I think if anyone can do it, it's probably going to be Docker, because of the image signing, the image signing that they're doing, the mesh work that they've done. I think we can probably combine that with some research efforts to be able to say, okay, we have this distributed system in our world that they can all talk to one another. The containers know who's the manager, who's the worker. Can you actually lift and shift that into absolutely any environment over the network? And I think that they have a good go at it. So, yeah, we love Docker.
Awesome. So, folks, I will probably... Yeah,
All right. So you talked about all the different integrations with the databases and things like that, and kind of how you roll and how you're rolling things out. What kind of throughput do you look at in terms of the amount of data that you can process when you're doing this? And I guess my bigger question on top of that is, how are you measuring it?
That's a great question. So the monitoring right now is thin. to be very honest. And I mean, I have Hartnell in the room, but right now we're actually struggling a little bit, to be honest, on how we're going to monitor these things. Other than we're using some sumo logic right now. We're using CloudWatch logs, but we're looking at two things. One, are we going to have to end up building our own system to do this? And two, what else can we pull out of these containers to not only measure throughput, but also start predicting it, right? Because one of the things we're going to have that's really nice in the consulting space is we're going to be able to see if we send 3 containers out or 4 containers out, all with 6 kinds of analytics applications, and 4 different kinds of data and 4 different sizes of data, how is the throughput being affected by not only the data, but the model and the kind of compute you're having in memory. But right now it's just typical syslogs that we're bringing in, CloudWatch and some sumo logic.
So you're talking about like looking at the possibility of like a heuristic scaling?
Yes.
Yeah, okay.
Exactly.
So you want to you can probably leverage the platform yourself in order to be able to do the heuristic scaling on the data that you're managing.
Exactly.
So
our own feedback loop.
Yes.
Exactly.
Yes. Okay.
Yeah, because we have a lot of companies have one domain, have a certain kind of data, whether it's banking or CPG. We have the ability to actually not only inform ourselves, but inform AWS and inform GCP and inform Azure on, hey, how are our systems running, right? Like if you're deploying these thousands of containers on all these kinds of platforms using all kinds of analytics across all domains, can you actually come up with a Gartner-like report, right? Of how this is running, and can that actually be something we can basically have as an asset inside of our system that's actually empirical and data-based, right? Because right now it's all like, meh, throw it in the AWS calculator, take some information, use your brain, and maybe it'll cost you $2 million a year. All right, maybe. Yeah, exactly. Right, exactly. Give or take a couple $1 million. It's not a great answer. So if we could actually come up with an empirical way and use our own system to do that, it'll be pretty phenomenal. But we need the feedback loop first. We need the customers first, and we should get something fun along the way.
Awesome. If no more questions, I will not torture you with more. Thank you, everyone. Thank you, Andrea.
Thank you so much.
Incredibly exciting.